Hereditary spherocytosis is the most prevalent cause of hemolytic anemia due to an abnormal red cell membrane and classifies as a type of congenital hemolytic anemia. Erythrocytes are unable to maintain their normal biconcave shape due to genetic mutations in membrane or cytoskeletal proteins that play a role in structural morphologic stability. Deficient or abnormal proteins may include spectrin, ankyrin, band 3, band 4.2 encoded by different genes. Normal erythrocytes have a biconcave shape and possess relatively high plasticity. With this shape, normal erythrocytes are able to buffer for small changes in osmolarity along with other changes in the intravascular environment. A lipid bilayer forms their membrane with proteins that adhere to the cytoskeleton and confer a normal biconcave shape, providing optimal surface volume relationship and adequate malleability, maintaining structural integrity and a proper ion permeability. Hereditary spherocytosis results from a deficiency in one or more proteins involved in maintaining adequate adherence between the cytoskeleton and bilipid membrane. As the cellular surface is unable to be adequately supported by the cytoskeleton, the cell adopts an abnormal sphere shape that decreases surface to volume relationship. As the abnormal red blood cell membrane holds a higher tension, their structure is increasingly fragile and unable to buffer for several intravascular imbalances, such as a decrease in osmolarity. In microscopical blood smear evaluation, spherocytic red blood cells appear as smaller round cells lacking the normal central pale area due to the absence of a normal biconcave shape. Most patients with hereditary spherocytosis have a positive family history. This disease should be suspected in any child presenting with splenomegaly, anemia, and hyperbilirubinemia. Patients may also present with asymptomatic cholelithiasis of undetermined etiology, commonly with a positive family history. The classic triad of jaundice, anemia, and splenomegaly is rare in neonates. The most common finding in this population is jaundice. Thus, hereditary spherocytosis should be considered in neonates with hyperbilirubinemia of unknown cause. The patient and other family members should be screened for features of compensated hemolysis like low hemoglobin, high unconjugated bilirubin, high lactate dehydrogenase, high reticulocytes, and high urinary urobilinogen. The anemia is usually normocytic. An increased mean corpuscular hemoglobin concentration should raise the suspicion of hereditary spherocytosis because it is the only anemia in which this abnormality occurs. The blood film will show spherocytes. The direct Coombs test is negative, excluding immune hemolysis. An osmotic fragility test may show increased sensitivity to lysis in hypotonic saline solutions. More specific flow cytometric tests detecting binding of eosin 5 maleimide to red cells are recommended in borderline cases. Sometimes a definitive diagnosis can be obtained only by molecular studies demonstrating a mutation in one of the genes underlying hereditary spherocytosis. Now, management. Due to the increase in erythropoietic activity compensating for hemolysis, patients with hereditary spherocytosis have increased consumption of folate. Therefore, folic acid prophylaxis should be given for life. Acute severe hemolytic crisis require transfusion support. In severe cases, consideration may be given to splenectomy. Splenectomy largely improves symptomatology in most patients, as the spleen is the principal organ where erythrocyte destruction takes place.
Thanks for watching. You may watch other videos in this playlist. Also, don't forget to subscribe.